Interpreting graphs and charts, we're going to look at some graphs and see how we can actually analyze them to find the information that we need to answer questions. So the first thing we need to look at are the parts of a graph. Remember, you always have a title, should be near the top, sometimes it's at the bottom. The title should reflect what type of data you'll find. Always look at the labels for the x-axis and the y-axis. Now remember the general pattern. If we start at the origin, going from left to right, the value should be increasing. From the bottom to the top, the value should be increasing. That's not always true, but that's just the general pattern. So let's look and see what a graph might tell us. Looking at this graph, if we look at our title, the wolf and moose populations from 1960 to 1999. So obviously I'm going to be looking at a trend of how the amount of wolves and moose have changed over the years. If we look at our x-axis, we have our year increasing as we go across 1960, 1965, 1970, so they're doing it in 5-year increments. And as we go from the bottom to the top, we're looking at the number of wolves on this side and the number of moose on this side. So let's look at the overall patterns. So the trend would be kind of following similarities until we see differences here and in here. So what happens to the moose population if the wolf population suddenly has an increase? Okay, remember, this would be like a predator-prey relationship. So as I get more wolves, I see a decline in the number of moose. Over here around 1995, we've had a general trend where the wolf population has been steadily decreasing, so it's at a low point. So we've seen a spike in the number of moose available because there's less predators to kill off the moose. Now something happened here around, let's just say 1997, 1998. We had a significant decrease in the number of moose, but a not significant increase in the number of wolves. What might explain this change in the population that took place that quickly? A change that When you see a drastic decline like that, that would indicate to me that there's been some sort of natural disaster. There could have been a disease among the moose population, possibly there was a forest fire. Something happened to cause a quick and significant reduction in the amount of the moose population. All right, so let's take a look at these graphs. If we look at our title first, the oxygen content in fish populations in a lake. So we're comparing essentially the amount of oxygen and the amount of fish that are surviving. So again, looking at our x and y axis for each one, the x-axis is representation in years, going again in 5-year increments. In our first graph, if we look at our y-axis, the amount of specific substances. So if I look at my titles, I'm comparing oxygen and sewage waste in the water. My second graph, relative quantity of fish, you see we have several different types of fish and how their population has changed. So let's look at our first one, oxygen and sewage waste. It clearly looks like an inverse relationship. Sewage waste is on a steady increase, but the amount of oxygen available is on a steady decrease. So as the sewage waste increases, the amount of oxygen decreases, creating that inverse relationship. Now apply what we know here to the population of fish. Which fish could obviously survive in higher quantities of sewage waste? If we look at the pattern, the only population showing an increase is the population of carp. All other species are showing a decrease. So as the oxygen level decreases, they're no longer able to survive. So when we look at graphs and charts, it's really important to look at the titles and we look for patterns and trends. You're going to be asked many times to draw a conclusion. So in this case, if I look at this, I can conclude that carp can survive in lower oxygen levels and higher quantities of sewage. However, the walleye could not survive with the oxygen decreased and the sewage increased. That's a conclusion I can make based on the trends of the graph. Always look for patterns across the entire graph and how they can change over time. So now you're going to practice using graphs and charts to answer questions.